next, I would love to introduce Yunzhi, whose presentation is titled Building Map-Ready Pedestrian Data.
Thank you. Hi, everyone. My name is Yunzhi, and I work at Meta as a data analyst. Today, I will talk about how Meta invests in pedestrian data in generations. So pedestrian data has become more popular these days because there are more relevant cases are rising, such as AR and navigations. Traditional methods, including manual mapping and validating directly on OpenStreetMap, or exploring the authoritative data sets at the government open data portals that are still two of our primary methods to get pedestrian data. So these traditional methods has their own advantages. Like for example, we got community support. We also receive local knowledge support. However, we are still facing challenge with these traditional methods. For example, the manual mappings is time consuming because the hand drawing process, and not all the city would have the pedestrian data available on the open data portal. So on top of the traditional methods, we Meta invests ML approaches to derive pedestrian data from both air image and street level image. So the ML approaches start ingesting data that are generated from the traditional methods, along with the data labeling. And then a lot of experiments are performed to develop the models. So once the model being deployed, we continuously monitor the model to identify and implement any improvements. The pedestrian data we have been focused on are sidewalk and crosswalks, and we develop models separately for each of them because their shape are generally quite different. These slides show some results of our outputs from the crosswalk model using Air ML image. So the crosswalk models on Air image are based on an effective models that object detection model that are developed by the Metasphere team. And then we add enhancements to allow the model be able to recognize a large variety of markings of crosswalk. And then we assign the confidence scores to each prediction result. The model now is capable to identify different crosswalk markings, such as the letters markings and the dotted lines, also color markings. We're also capable to identify crosswalks that are under the shaded area. The sidewalk models using air image is different. So how it works is it first identify all the vehicle rows on the air image, and then predicts the sidewalks on both sides of the vehicle roads. We then use additional features such as buildings and trees to allow the models to be able to focus on areas that most likely contain sidewalk. So once we have the enhanced results, we convert those data into 2D vectorized 2D data. For street level imagery, we also have models differently for sidewalk and crosswalk, but they both use the mapillary detected objects. So how the sidewalk model work on street level imagery? We first collect all the clear imagery alongside the roads that with sidewalk objects, and then we extract the objects from each street level image, and convert the sidewalk object into a sidewalk line string. And then we connect the sidewalk line strings from all the imagery that alongside the roads and to make the full geometry of the sidewalk. Our crosswalk model using street level imagery are still under development, and hopefully we can share more as they of the map. As the last step, we combine the results from both traditional methods and the ML approaches, and we work on the conflation and post-processing, then produce the final outputs that are more accurately representing the sidewalk and crosswalk. We surface some of those high confidence results onto rapid through related challenges. currently. So this model only has been around a year old, so they're pretty young in general. There's still improvements can be made on the models. And if you have any questions and feedbacks, please don't hesitate to reach out to us. Thank you.